Hello and welcome back to the Learn Electronics India channel. I'm Meghna, and in this video, we will be learning about a basic electronics project. We have successfully completed learning about the fundamental concepts involved in basic electronics, and now it is time to put all that knowledge into practice. So in this video, we will be learning about the voltage divider circuit, which we had studied about in the earlier videos. So a voltage divider circuit is basically a circuit consisting of resistors connected in series. Series means it is connected end to end. So if we start from the source, then that is connected to one resistor and the other end of the resistor goes to the next resistor. That we call it as a series connection. For simplicity, we will be just dealing with two resistors today. Whatever the voltage we have at the input, we get a fraction of that input voltage as the output voltage across one of the resistors. So in this case, I have taken R2 to be the resistor across which we will be measuring our voltage, and that voltage I have named it as V out, or the output voltage. So the formula for this is V out equals V in into R2 divided by R1 plus R2, which means suppose we do not know the value of current, then just by knowing the value of these resistances and the input voltage, we can find the output voltage or the voltage across each of these resistors using this formula. Since we are measuring the output voltage across R2, in the numerator, I have R2. Suppose I would be measuring the voltage across R1, then I will have R1 in the numerator. The components required would be a power supply that will supply the input voltage, two resistors. LED is optional, but here I am using it to understand the intensity of the LED that glows, so that we will know how much voltage is safe to be passed through the circuit. Connecting wires to connect all these components. We will use a multimeter to measure the voltage across R2. So multimeter is a device that will measure multiple parameters such as voltage, current. We can set the knob to the parameter that we need to measure. For the ease of understanding, let us do this project on an online simulator. So I'll be using an online simulator called as Tinkercad. Online simulator is a platform where we can virtually work on projects. Let us now go to the Tinkercad website. So this is my Tinkercad homepage. You just have to go to Google and type Tinkercad. Click on the first link that you get. If you're already a user, you can just log in. If you're new to the platform, just log in with your personal account. Once you've logged in, this is how the page looks. All the projects that you've designed will be visible here, and you can create one by clicking this create. Now, since we'll be designing an electronic circuit, I'll be using circuit option. So I'll click on this, and this will create a new circuit. Every circuit will have a name by default, something like this. So I will rename this as voltage divider and click on enter. So that name gets changed. Now this is where I will bring the components and I will do the connections. On the right hand side, you have different components. You can also search the components here and you can choose the components, whether it is basic, Arduino, microbit. All these things are advanced. For now, we'll just stick to basic. On the top, there are some options wherein you can copy a component, you can delete a component, you can undo and redo, you can write comments, or this is called as notes, and you can hide that note if needed. This is the wire. So this is the type of the wire you need, and this is the color of the wire. This option will rotate a component and this option will mirror the component. So let us start by taking resistors. Choose under components basic, and now let me type resistor. So I will get a resistor here. Now I want to rotate this resistor, so I will either press R on my keyboard. Alternatively, you can also place it here and then use this tool. Let us not worry about the resistance for now. I'll take 2 resistors and I will place it here. Next, we need a voltage source. So I will type it as power supply. This is the power supply. Here you can vary the current as well as voltage. Let us stick to voltage because that would be enough for us. So I will place it here. And then we also need an LED. So here is the LED. Just click on it, bring it here, and once again, click. Next, we need a multimeter. Let me place it here. Now I will connect the wires. First, I will choose red and this positive. I will connect it to one end of the resistor. Next, I will let this be green and I will connect terminal 2 of the resistor to terminal 1 of the another resistor. Now again, let me take a black wire because from negative terminal, it is usually represented in black. So that I will connect it to other end of the resistor. Second resistor I mean. Alright, now I will connect this LED across the resistor. So let me take the color green to terminal 1 and then this to terminal 2. If we observe that the LED never turns on in any of the cases, then we will have to interchange these terminals. Let me try and place this multimeter over here. Yeah, looks fine. So this multimeter is now set to voltage. Now what I'll do is I will take color black, connect negative terminal to the terminal 1 and take color red, connect positive terminal to another terminal that is remaining. Yeah, so the connections are now done. Now let me change the resistor values. Let us keep this in ohms and let this be 50 ohms for now. And let my R2, the name is 2. Let this be 220 ohms. So R1 is 50 ohms, R2 is 220 ohms. The voltage, let us give 5 volts is fine. So 5 volts is fine and let us see what happens. After completing the circuit, you have to start the simulation. That option is available here. What this will do is, this in real time means that we are turning on the supply. So I will start the simulation and now the supply is on. 5 volts is the voltage that is going. And across R2, we are measuring minus 4.07. Ignore this negative sign. It just means that we have to interchange these terminals. So instead of connecting the positive to terminal 2, I have to connect it to terminal 1 and this negative terminal to terminal 2 of the resistor. For now, let us just focus on 4.07 volts. According to our knowledge, since resistor R1 has low resistance, it is taking less amount of voltage, and since R2 has high resistance, it is taking more amount of voltage. But we have seen that LED hasn't turned on. So what I'll do is I will stop the simulation and I will interchange these terminals. So I will bring this here and I will click on this wire and I will bring it here. Now let us see what happens. I will start the simulation and you can see the LED is on, but the voltage has also changed, which means after this resistor R1 has consumed some amount of voltage, whatever the remaining voltage we have from that, LED has also used some amount of voltage to glow and remaining voltage is shown across R2 as 2.26 volts. There is some disclaimer symbol here and if I click if I just move my cursor over there, it says current through LEDs 44.5 milliamps. Recommended maximum would be 20 milliamps. So let me reduce the voltage now. I can either do that by moving this knob like this or by changing it digitally here. So let us make this 4 volts. LED is still on and it still says recommended current is less than 20. So let me reduce it to 3 volts. LED is working fine now. Suppose I increase it to more than 5 volts. Let us say a power supply I'm giving of 8 volts. It still shows a disclaimer. Let me increase it to 10 volts. Now you can see some bursting symbol appearing on the LED, which means in real time, if we supply a voltage of 10 volts from this power supply, then we would observe the LED blasting off. So this is one case where we have the resistance R1 and R2 to be constant, but I'm changing value of power supply and I'm studying the circuit, which means ideally the voltage for the LED to glow properly should be less than 4 or less than 4 volts. Between 3.5 is fine, ideal. I hope you're also able to observe the intensity of the LED. So after I made it 3.5, the LED got little brighter. Now if I make it 3, intensity got reduced. Let me make it 2, and you can see there is very little light going from the LED. So this is the reason I used an LED to study how the voltage affects the LED and also the resistor. Alternatively, as I increase the voltage across resistor R2 kept changing. Now let us fix this to 4 volts, or let us fix it to 5 volts, and let us change the resistor value. So I will keep it to 60 ohms and see what is happening to the voltage level. It has become minus 2.2 now. Let me make it 70 volts. It become minus 2.16 or just 2.16 volts. If I make it 100 ohms, it became 2.08, which means as I'm increasing the resistance of R1, the voltage across R2 is decreasing, which again practically proves the theoretical knowledge that we have, that as resistance increases, then the voltage also increases. Let me increase this to 1000 ohms. Now the voltage changed to 902 millivolts. Earlier it was in volts. So this is how we study the pattern or the behavior of the different components in the circuit. This was the basic voltage divider circuit. You can increase the complexity by increasing the number of resistors and study the circuit. That was about a basic project which we implemented based on the knowledge that we had learned from the basic electronics series. Hope you had fun learning. Thank you.